All right, guys, in this platform, we shall try by all means to work out the revision which was carried out in the exam of April 2024. So that is our mathematics N5. So make sure when you're attempting these typical questions, you go through each and every part, understand how to attempt these questions, because in most cases, it's actually a repetition that you're going to have. So that is what you're going to have. Remember your answers to 3 decimal places and make sure that you write everything neatly so that they can be able to see whatever that you are writing there. So you're not going to waste much time. Let us quickly rush through the questions that we were given. On question number 1.1, we're given determine the following limit. So that was our limit and we are given 4 marks for that. Okay, let's check how are we supposed to attempt this typical question. We are given there to determine the limit as x is approaching to 0. So you're given as x is approaching to 0, and that was e to the exponent of x over e to the exponent of x minus 1 over x. So remember that the limits we consider in terms of a fraction where you're considering two fractions that you're comparing, maybe f of x and gx. These are two different functions that you must compare as the limit is applied when x is approaching to 0. You substitute those limits. But it must be from a single fraction of f of x over gx. Whenever you've got a fraction, it must be a single fraction like this. So meaning you're supposed to combine this into a single fraction so that we have got f of x over the g of x. So let us try combine this. We are given e to the exponent of x over e to the exponent of x minus 1 over x. Remember, this is your n3. What we do not have here is x. So we are going to multiply by x over x. All right, we take this one to this side. So we multiply by e to the exponent of x minus 1 over e to the exponent of x minus 1. So as we can see, the moment we do this, the denominators are the same. X, e to the exponent of x minus 1, they are the same. So the advantage is that you can combine the numerators together because of these denominators, which are the same. The denominator of x, e to the exponent of x minus 1, you just combine whatever that you're seeing on the numerator as it is. So that is x, e to the exponent of x minus, take note there's a minus 1, but it must affect this e to the exponent of x minus 1. So it must be in a bracket, e to the exponent of x minus 1, so that everything will be affected by that negative that you're given. So in this case, we can expand the bracket. Let's see what you're going to have. That's x e to the exponent of x negative times the first term. That's negative e to the exponent of x negative there. You are going to obtain a positive 1. All right, so that's x into e to the exponent of x minus 1. So if you're to consider, yes, we've got a single fraction and we do not have anything in common. So we have got the concept of the f of x over gx. So with this, let us substitute now the limit that you're given and see what is happening with this given term fraction that you're given of x e to the exponent of x minus e to the exponent of x plus 1. Everything here is x. You can even expand this bracket here. The reason is that if you expand this, you can see it is the same term as this one. So do not worry about that. So just expand. It's going to be x e to the exponent of x, then x times minus 1, that's a minus x. You can expand, you can even leave it like that. There's no problem. So this is for you to now test the limit that you're given. Remember, you're supposed to test this limit, but because of the fraction that we are given, it was going to be difficult. But if we've got a fraction like this, now we can test. In place of x, we are going to substitute a 0 in place of x. So that was going to be on top. That was going to be 0 minus 1 plus 1, which is 0 over. That was going to be a 0 again. Remember, when this happens on your f of x over gx that you're given, you're going to apply the L'Hospital's rule, which is finding the derivative of what you're given. So you're going to differentiate f of x, you're going to differentiate gx. Substitute the limits again. So let's differentiate this. So if we are to differentiate the first part here, it's a product. Two terms, x and e to the exponent of x. So remember, from our product, if you're given y is equal to u, v, the derivative there of y with respect to x is going to be taken as u, the first derivative of v, plus v, the first derivative of u. So in this case, this is our u, this is our v. So from the first part, we are going to have u in this case. All right, so the first part we're gonna have u, let me just write it straightforward here, which is our x times the first derivative of the v, meaning to say the first derivative of e, remember it remains as e, okay, plus v, our v, which is e to the exponent of x, times the derivative of u, the derivative of x, which is 1. Remember, that is the coefficient of x there. We are done with this part of the product. Okay, we move on. Minus the derivative of e to the exponent of x. We saw that this one remains as it is. Okay, the derivative of 1, that's a 0. Remember, 1 is a constant. So its derivative, that will be a 0. If you were to consider this part here, it is the same because that is the part that we differentiated on top there, the product. So this is the answer that we got from our product. So we are going to rewrite that as it is. That is, we still have the same answer, x e to the exponent of x plus e to the exponent of x times 1, which is just e to the exponent of x. So this one is a repetition of that product that you applied there. All right, then the derivative of minus x, that is minus 1. Okay, so that is what you're going to have in this case. On the numerator, we have got the like terms, e to the exponent of x and e to the exponent. These are the same. So meaning to say this will cancel. There we've got a 0 there. So meaning to say before you apply the limit, you can also just try to simplify. Just simplify. So that is the product there of x e to the exponent of x, everything over x e to the exponent of x plus e to the exponent of x minus 1. So in this case now, we can apply the limits. Let's see what's going to happen. So in place of x, that's a 0 there. That's a 0 in place of x, wherever there is x. So this part on the numerator, it was going to give us a 0, which is true. But if we check in the denominator there, we are going to have a 0 here. We are going to have a 1 minus a 1, which is a 0. So that's a 0. That's a 0 again. So we are back again to the 0 over 0, guys. And we know that once this happens, the derivative, just like previously, apply the derivative of the numerator, the derivative to the denominator. So that is, in this case, we're going to repeat the derivative. That means the limit as x is approaching to 0 of, so here it's not a matter of fact because already this derivative is there. Remember, it's just a repetition of what we differentiated before. The x times e to the exponent of x, we saw that this is going to give us x e to the exponent of x plus e to the exponent of x. So it's just a repetition of what you differentiate, a product. So that was going to be x e to the exponent of x plus e to the exponent of x, okay? Which is the same thing with this first part here. It's a product again of what we had before. So its derivative still going to have the same thing, e to the exponent of x, okay? Then we differentiate this, that is e to the exponent of x. minus 1, that's a 0. Remember, the derivative of a constant, that's a 0. All right, so in this case, we can try and substitute the limits again, because we can see that yes, we can simplify this, add, that's not a problem. We can just substitute when x is a 0, that's a 0 here, that's a 0 here. But if you see on this part, e to the exponent of a 0, that's a 1. E to the exponent of 0, that's a 1, that's a 1. So this one is not going to give us 0 over 0, no, because there we are going to obtain a 1 plus a 0, which is a 1. So that is going to give us a 1 over. So it was actually supposed to be 0 plus 1. Here, if you substitute, that's a 0 plus e to the exponent of a 0, that's a 1 plus another 1. So that was going to be 1 over 2. So if you had to check properly, this was going to be simplified further. You can simplify further from what you are given. So that is the limit. The derivative, if you've got the 0 over 0 concept, or it can be from the infinity over the infinity concept. If that happens, you apply the derivative, then substitute the limits until you are not obtaining that. Like in this case, we are obtaining the exact value from what we are given. All right, so these are your typical questions. 1.2, for which values that is this function discontinuous, that is determine the values of x for which our f of x is discontinuous, this f of x that we are given. So remember, for this to be discontinuous, it's all about the denominator that you're given. It must be equal to a 0. So that we are talking about a function that does not exist at all. So that must be equal to 0. All right. So in this case, you're given 1.2. So remember, our f of x, it was x squared minus 5x plus 4. So do not even focus with the numerator there. You just focus with them, with the denominator in that case, that is of this fraction. For this to be equal to 0, that's the whole function of that we're given will be discontinuous. So e to the exponent of x squared minus 9 minus 1 must be equal to 0. We have formed an equation which you're supposed to solve. What type of an equation is this? All right, so if you have to consider these are exponents, but in order for us to work out these exponents, we must have something that is common. There is e, there is a minus 1. Okay. If we had to take this to the other side of the equation, the minus 1, it was going to be a positive 1. Remember, 1 is a number that can be written in any base. It can be the base of 10, the base of 2, any base that you can think of. But that base must be raised to the exponent of a 0. Any number to the power of a 0 is 1. So meaning to say, by writing this in the base of e, why in the base of e? Because that is the one that you have here. If it was in the base of 2, you use 2. If it was in the base of 10, you use 10. So because already here we are given a reference, which is e, we are going to write the same one in the base of e. So in the base of e, that is e to the exponent of a 0. Why writing this way? Because we do understand that if the bases are the same, if these bases are the same, automatically our exponents will be equal. So this means x squared minus 9 must be equal to 0 because of these bases that we are seeing. These exponents will be equal. You had an equation that we wanted to solve, which is an exponential equation. In solving it, you are forming another type of an equation. What type of an equation is this? We are now having a quadratic equation. It has nothing to do with exponents this time. We are now having a quadratic equation. So how can we solve this? We can take the minus 9, so that it becomes a positive. Remove the square both sides by the square root. That will be plus or minus 3. So meaning to say when x is plus 3 or minus 3, this function will be discontinuous. That is from what the denominator concept is, from this denominator concept that you are having. But as you are formulating equations now, how are you going to solve that equation? The type of equation that you have formulated. So it depends with the equation that you're going to have. All right, so let us check question 2. 2.1, determine from first principles f of x is equal to this, and that was 4 marks. Okay, from first principles. As we do understand that fractions of this nature, they're actually easier to work with. It's just a matter of your substitution there. So you're given f of x is equal to 5 over 7x plus 2. Remember your formula, and from that formula, you just need to work out what is needed on the formula. Remember, the first derivative with respect to x is obtained on a condition where limit as h is approaching to 0 of f of x plus h minus f of x, everything over h. So in this case, f of x is already there. So we are going to need f of x plus h. Then we subtract and so on. So let's start with f of x plus h. F of x plus h simply means in place of x, substitute x plus h. So that means we've got 5 over 7 in place of x, substitute x plus h. That is what it means. But there is a plus 2, which is there. Take note. So you have to add that too. Expand the bracket by 7. You can expand this so that you have just normal part work with. Yes, we can use as it is. It's not a problem as long as you understand it. So by 7, that's 7h plus 2. So this one, you just expand these 2, then 2 is just added. So this is your f of x plus h. But as we can see from the formula, we need f of x plus h minus f of x, the difference of these two. So we are going to subtract f of x plus h minus f of x. So what are we going to have if we subtract these two? Okay. F of x plus h is this part that we obtained, which is 5 over 7x plus 7h plus 2. Then we are subtracting f of x. Originally, what we had, 5 over 7x plus 2. Okay. Now I want you to see something. We had a fraction previously that we added. I just say we can interchange, just to interchange. This here, you take it this side. This here, you take it that side. Just like that. So how am I going to take it? It is going to be 5 into this. So you have got like 7x plus 8. So it's going to be 5 into 7x plus 2. So we are going to be having now the 7x plus 2 into this bracket. So instead, just combine. That is the idea there. So you're going to have 7x plus 2 into 7x plus 7h plus 2. All right. So you take this, take it this side. The 5 multiplies this. This 7x plus h, this one, it is multiplied to minus 5. So it will be minus 5 into 7x plus 7h plus 2, just like that. Easily like that. This one multiplies this one multiplies this, then you take the fractions. So in this case, if you start with this one, there's no problem. You can start with this bracket, you can start with this bracket. In the denominator here, there is no effect. Which part are you starting with? Okay, but as you can see from our numerator there, there's a need of us expanding of the brackets, collecting of the like terms. All right, that's 7 and 5 by 7, 5 by 2. That was going to be 35, x, 5 and 2, which is 10. Again, minus 5 and 7, minus 35x, minus 5 and 7 here, minus 35h. Minus 5 and 2, that's a minus 10. Everything was going to be into 7x plus 2 into 7x plus 7h plus 2. Okay. We can simplify. Remember, we are still adding, we are still on under the same fraction, combining what we are given there. So you can see they're like terms, 35 minus 35, 10 minus 10. So that was going to be minus 35h remaining. Everything over 7x plus 2 into 7x plus 7h plus 2. So this is what you're having as f of x plus h minus f of x. Now let's conclude. What do we need here? We need this whole thing divided by h. So we are going to take this f of x plus h that we are given, this f of x plus h minus f of x. We divide this now by h. So the moment you divide by h, it means also this side, you are going to divide by h. Dividing by h cancels the h in the numerator. So meaning to say, our f of x plus h minus f of x over h is the whole of this fraction that we are seeing that is remaining, this part. So this is the part that you're going to take into substitution of this part. All this part that you have been working, all this part, it is representing this formula that we are seeing here, this formula. So we are going to substitute. So meaning to say the first derivative with respect to x is equal to the limit as h is approaching to 0 of all this. We have simplified this, everything. This is what we got. From the fractions, we are taking this part of our fraction as it is. We have subbed everything. Everything is there. So we are taking this as it is. All right. So that was minus 35. Minus 35. Remember the h cancelled there. So this was into 7x plus 2 into 7x plus 7h plus 2, like this. Okay. From this, we are given as h is approaching to 0. As h is up, meaning to say where there is h, we are going to put a 0. So what are we going to remain with? That's the first derivative there. We have substituted this, so this is going to be minus 35 over. So the first bracket, nothing was affected, nothing changed. But in the second bracket now, this one is having a 0. So you are left with 7x plus 2. So you're going to be left with 7x plus 2 when you substitute this limit. So this is our answer. So we can also write this answer as, remember, that's the product of two brackets. You can have it as a squared, 7x plus 2, everything squared like this. So that's how you can simplify this part. That's how you can simplify this part. So given these typical questions, so you see this part, if you try to work out every working year is supposed to be shown and you show it aside. What we have obtained here is the one that you're simply working with on the substitution of the limit, then simplifying further. All right, so that was our question. The first principles, and we are given 4 marks for that. All right. 2.2, determine the derivative of y with respect to x, which is dy dx, in each of the following cases. Simplification not required. We are not simplifying anything. Okay, let's check the first one. The simplification, remember, it is not required. Okay, so the first one, that was our 2.21, you're given y is equal to 1 over 5. That is sec to the exponent of minus 4. We have got 4 plus x cubed. So remember, when the simplification is not required, let's start with the power first. Focusing with the power, drop the power. Remember, you subtract 1. So we are going to drop the power. So the derivative of y with respect to x is going to be, so if you drop the power, that is minus 4 times 5, 1 over 5, it will be minus 4 over 5. Sec you subtract 1 on the power. So remember the common derivative concept. You drop the power, you subtract 1. So that was a minus 5. And we have got 4 plus x cubed. Okay. Times the derivative of a sec. Remember a sec. It's sec tan. So we are going to have sec tan. So that will be sec 4 plus x cubed tan 4 plus x cubed. We are done with this. We move on to the algebraic expression. So you multiply to the derivative of the algebraic. What is inside it? That's the derivative of 4, that's a 0. The derivative of x to the power of 3, that is 3x squared. Okay, so this is what you're going to have at the end. So remember, the simplification there is not required. Simplification is not required. So you can just leave your answer like this. It's fine like that. So the power, the trig, the algebraic, just like that. You can differentiate anything of that nature. All right. Let us consider 2.22 again. Simplification is not required. Okay, let's see there. We're gonna think of our quotient rule. Okay, that's 2.22. We are given y is equal to the square root of 2x cubed plus 1. Okay, this was over the square root of 2x cubed minus 1. So I just want you to know, okay, this is your u, this is your v, which is fine. Just write it also aside so that you just understand what is happening. Remember, to the power of a half means the square root. So this is same as 2x cubed minus 1 to the power of a half, okay? Just leave it like that. From the derivative, we do understand that here we're supposed to obtain the derivative of y with respect to x. From our formula, it was supposed to be v, first derivative of u, minus u, first derivative of v over v squared. Okay, so let's apply that and see. So the derivative of y with respect to x, v, is the denominator as it is. So instead of you taking this part, which is not simplified, take the simplified one, the square root of what? 2x cubed minus 1. Okay, that's our v. Times the first derivative of u. So u, this is our u. You're supposed to differentiate this. So for you to understand better, differentiate this one that you are seeing here. Remember, you differentiate the power, you drop the power, subtract 1. So that will be 2x cubed plus 1. If you subtract 1 here, that will be a minus half times the derivative of what is inside the bracket. Remember, function of a function. So the derivative of what is inside the bracket, 3 times 2, that was going to be 6x squared plus a 0, the derivative of 1. Okay, so we have differentiated the numerator, which is our u. So this is the first derivative of u. Minus u, our u, we are just going to take as it is this time. That is the square root of 2x to the exponent of 3 plus 1. But this here has to be multiplied to the first derivative of v. So the first derivative of v, just like like the first part, it is easier for you to differentiate from this side here, from what you understand. You drop the power, so that is a half. You subtract 1 on that power. Remember your derivative concept, drop the power, subtract 1. So that will be a minus half. Then you differentiate what is inside the bracket, just like the previous case. You differentiate what is inside the bracket. So 3 and 2, that was going to be 6x squared. Okay, minus a 0, which is just 6x squared. We are done. So this is from the numerator part, but in the denominator, what are we having? Everything is supposed to be divided by v squared. So everything is affected by v squared. Okay. Let me just try and reduce this one. So everything here is going to be divided by v squared. Okay, so this is now closing up my other numbers here, something like this. So our v, remember the v we are talking about the square root of this part. So there's the square root of 2x cubed minus 1 like this, everything squared. That's v squared. So since the simplification is not required, you can leave it like that. Okay, simplification is not required. You can just leave it like that. So that is what we could have done whenever you're given this part of simplification not required. Do not worry about much. 4 marks, there you obtain your 4 marks, okay? Then 2.3, given this part here, calculate the derivative of y with respect to x with the aid of logarithmic differentiation. Okay, then we've got 4 marks for that. So remember your logarithmic part, you're gonna introduce the ln, then you simplify as far as you can. All right, so I'm just gonna have this one here. So this was given as 2.3, where we are given y is equal to 3x plus 5 to the exponent of 3. And everything we are given as the square root of x to the exponent of 4 minus 1. Okay, so there we just need our logarithms, the laws of our logarithms. So if you had to introduce the ln, which is the log this side, we introduce the log this side. That means you're going to obtain the ln of y is equal to. So far we have got 2 fractions. We've got a fraction that we are given. You're having 2 terms. What we are given in the numerator and in the denominator. So consider as that. So remember the ln of a over b was taken from the ln of a minus the ln of b from our n3 logarithms. We subtract. So meaning to say this is the ln of a, this is the whole part representing our a. So that is 3x plus 5 to the exponent of 3. Minus the ln of b, that is the ln of this part that we are seeing, the square root. So there, the square root, if you write it as a power, remember, it is same as to the power of a half. We are supposed to write as the square root here. But the square root, guys, is the same as to the power of a half. So having the power, we can drop these exponents. Remember, a log, when affected by an exponent, you can drop the exponent to multiply the logarithm. So meaning to say this was going to be 3, the ln of 3x plus 5. Okay, you drop this one, that is minus half the ln of x to the power 4 minus 1. This is what you're having. So at this stage, you can differentiate. So the derivative there, we are supposed to find the derivative with respect to x, whatever that you're finding. We are supposed to determine the derivative with respect to x, the derivative here with respect to x. So what is the derivative with respect, where there is a ln, but you're differentiating with respect to x? So we use the implicit function concept. So that is going to be 1 over y divided x. You are not having x. So you differentiate in terms of y, but your answer, you multiply it by divide x. Okay, so this is equal to, there we have got x. So we're going to differentiate straightforward. Remember the derivative of a ln. How do you differentiate a ln? If you are differentiating, a ln is the first derivative over f of x. So meaning to say in this case, it's going to be 3 times the first derivative of our f of x. That's our f of x from the first one here. So what is the first derivative? That is 3 over f of x, which is 3x plus 5. Minus 1 over 2 times the first derivative, ln, the first derivative over f of x. So you differentiate what is inside the bracket, 4x to the exponent of 3 over what? X to the exponent of 4 minus 1, which is our f of x. First derivative over f of x. That's to differentiate a ln. So with this, we can simplify further this other side. That is 1 over y dy dx is equal to 3 times 3, because this is the same as 3 over 1. So you can multiply 3 times 3, that is 9. 1 times this 3x plus 5. Okay, the same thing. 1 over 2, if you're to multiply, this was going to cancel actually. So it was going to be minus 2 x to the exponent of 3 over x to the exponent of 4 minus 1. So this can cancel with this one. So it was going to be a 2. We do not need this. So how do you remove this? Multiply by y this side. You also do the same thing on the right-hand side. You multiply also by y. So this cancels. You have dy dx. Remember, what you need is dy dx, the derivative of y with respect to x. So it is equal to y into this. But what is representing this y? It is that function that we were given before. Y is equal to the whole of the function that we were given, the question that we had before. Remember, that was your y. So in place of this y, we are going to substitute what we were given. That was 3x plus 5 to the exponent of 3 over the square root of x to the power 4 minus 1. That is the y that you're given. And this whole part remains as it is. So that is 9 over 3x plus 5 minus 2x cubed over x to the power 4 minus 1. So you can simplify it that way. There are so many ways that you can try to figure out, but considering the derivative there, these are the steps that you're supposed to follow up. You introduce the logarithms. By introducing the logarithm, apply the laws of the logarithms before differentiating with respect to x. Remember, we need the derivative of y with respect to x, so you differentiate with respect to x. It is the same application of what we are seeing on 2.4 on an implicit. 2.41, determine dy dx. So we are supposed to differ with respect to x, even though some other terms that we are seeing there is the part with y. Okay, let's see. So that's an implicit that you are given y squared plus x squared to the exponent of 3. Okay, sorry for that. This is equal to 8x squared y squared. So in most cases, you think, okay, there's power there. Let me just expand this, then find the derivative of each separately. Guys, also the part of our implicit functions, they do have the concept of the chain rule. This is a derivative. So we are not limited to say because it is the part of implicit, we cannot apply the functional function concept. It's still there. What is the concept of a function? The derivative of the power, you differentiate as if you are looking in the outer part of the bracket. You're talking about the outer part of the bracket. Let me indicate it this way. This is our bracket. You differentiate not what is inside, but you differentiate the bracket. So you drop the exponent, which is 3. You remain with y squared plus x squared, not affected. But we subtract 1 now on the exponent. Remember the concept, drop the power, subtract 1. So this will be a 2. How were you differentiating before these other terms after this? You were multiplying to the derivative of what is inside now, the bracket. The derivative of what is inside. So what is inside? We have y squared and x squared. Let's differentiate y squared. Are we having x there? No. So we differentiate it in terms of y. But do not forget to multiply by dy dx. What about x squared? There is x there, so we differentiate as usual. That is 2x. You're done. So this is the derivative of what is inside the bracket, which is giving us an expression This is the derivative of the outer bracket. You look at the outer bracket, you drop the exponent, you subtract 1. Function of a function concept. So please make sure that you work on your function of a function as much. So you've differentiated the bracket the same way that you use your function of function. On the right-hand side, there is a product. This one now is a product. So remember the product rule. So you're going to take this as my u and this as my v. U, the first derivative of v, plus v, the first derivative of u. So our u, that is 8x squared, times the first derivative of v. V is y squared, just like how you differentiated this y squared. So it's going to be 2y times the derivative of y with respect to x, because we do not have x there, plus v, our v, which is y squared. The derivative of u is 8x squared. So that one is a function of x. You just differentiate as usual, 2 times 8, which is 16x. So this is what we are having. We need the derivative of y with respect to x. Remember, that is the major part of our question. We have it here, we have it here. So you have to combine these. But before that, what is happening? This is a bracket expanding a bracket. So we're going to multiply this into this bracket so that we have got 2 terms. So this bracket multiplies the first term, that is 2 times 3, it's going to be 6y into the bracket of y squared plus x squared like this, but there is a dy dx. Okay, so this part multiplied here, it also multiplies here. So it's 3 times 2, which is going to be 6x. The bracket as it is, y squared plus x squared to the exponent of 2, okay? This is equal to, we simplify also here, 8 and 2, which is 16, x squared, y dy dx, okay? Here we can simplify again the 16x y squared, okay? There is a dy dx, like I said, common. So we are going to take these 2 terms. So I'm going to take this part with the dy dx, meaning to say I'm going to transpose it to the left-hand side to where this other dy dx is. So already on the left-hand side, there is 6y into y squared plus x squared squared, dy dx. If I take this to the other side, it becomes a negative. So that's negative 16x squared y into dy dx. And this is equal to what? Already what you are given on the right-hand side, which is 16x y squared. Then we take this term, because it does not have dy dx, we take it to the right-hand side, just like what we did this one with dy dx. So it was a positive. The moment that it crosses the equal sign, becomes a negative this side. So that's negative 6x into y squared plus x squared squared, like this. So guys, as we can see, there is a dy dx and a dy dx, and the major part is that we do need this dy dx. So what we are going to simply do is to factor it out. By factoring out this dy dx, we are remaining with what? What we are remaining, the bracket, is the major part that we are going to focus with. So the moment we do factor this one out, we are remaining with this part as it is, which is 6y into y squared plus x squared squared, like this. If we factor this one out, we are going to remain with minus 16 x squared y, like this. So this is what we are remaining with, which is equal to the right-hand side. Nothing is affected there. So far, we do have this as it is, so this is not affected. So as we can see, guys, what is it that is affecting our dy dx? This one, it is the bracket. So we are going to remove this bracket. so that we remain with this dy dx. So what is happening? It's a product. So you simply have to divide it on this side. So meaning to say it was going to be 16x, that's 16x y squared minus 6x into y squared plus x squared squared like this, everything over this bracket that you're dividing with. So that's 6y into y squared plus x squared squared like this minus 16x squared y. So this is how you could have simplified to the last part. Guys, I hope we are together there. So the implicit of a function part is important when it is like this. To understand also the application of a function while it's working with the implicit function. All right, so let's consider the other part of this question. It was to determine the equation of the tangent. That's a continuation from this function that we are given. But we need the equation of the tangent to the graph at the point minus 1, minus 1, 1. So it's minus 1, 1 there. So given at a point, that's 2.42 at a point, given as minus 1, 1, we are given the x value and the y value. Remember, the equation of a tangent from the concept of y is equal to mx plus c. M is the gradient, and the gradient is supposed to be determined from the dy dx that we are given. We are simply substituting. Where there is x, you substitute minus 1. Where there is y, you substitute a 1. So m was simply from our dy dx. Remember, dy dx is the gradient expression. It is the expression of a gradient. By substituting the value of x and y, you are finding the numerical value of that gradient. So it was going to be 6 in place of x, minus 1 in place of y, that's 1 squared, minus 6 in place of x, minus 1 into y squared. Guys, y squared, that is 1 there. X squared minus 1 squared, that will be 1 squared. Okay, so this is over 6 times y. Y is 1, 6 times 1. Okay, this one, guys, is just 1 plus 1 squared minus 16 x squared. X squared, guys, is 1 times 1. Remember, minus 1, guys. Minus 1 if you square it. So this was going to be a positive 1 if you simplify it properly. It was going to be positive 1 as our gradient. So having the gradient and a point, it's enough to determine the equation. Remember, our equation from y is equal to mx plus c. M is the gradient. That's 1x plus c. So you can substitute the point that you're given, x, y, in place of y, that's 1. In place of x, that's a minus 1 plus c. So 1 is equal to 1 times minus 1, that's minus 1 plus c. Transpose this, that was going to be 1 plus 1, which is 2. So c is equal to 2. So therefore, our equation was y is equal to mx, which is 1x, plus c, which is 2. So 1x is just same as x, guys. Okay, so in this case, that was what you're supposed to have obtained as the equation of the tangent. It is a continuation of what we had from the implicit function. You determine the derivative. It's just a continuation there. That point lies on a function, but considering the equation of a tangent, that's a straight line. All right, so question 3, you're given 3.1, f of x. So there we are given f of x as 3.31. Determine the coordinates of the turning points of f. Okay, so remember, the coordinates of the turning point, the first derivative must be equal to 0. Our f of x is given as x cubed minus 2x plus 3. And at any turning point, we know that the first derivative is equal to 0. So what is the first derivative of this function? First derivative, we're going to have 3 x squared minus 2. So this must be equal to 0. So equate this to 0, guys. We can solve, transpose this. That will be 3x squared is equal to positive 2. Divide by 2, by 3 by 3. That's 2 over 3. There is a squared, so introduce the square root both sides. So x is equal to plus or minus. Remember, the square root of any number is plus or minus. So it was going to be something like 0.816 plus or minus. So there are two values that you're talking about at the turning point. So you're going to have the first turning point at 0.816. And you substitute into the original function in place of x. So where there is x, you're going to substitute. That will be 0.816 to the exponent of 3 minus 2 into 0.816 plus 3. So that will give you something like 1.911. And the second turning point, it's on a condition where this x now is a negative 0.816. So in place of this, I'm going to put a negative. So this time you are going to obtain 4.089. Okay, so that was our turning point concept. So the turning point concept is just a direct part that you are to consider. All right, let's see the other part. Draw the table from this information. All right, so draw the table from -2 to 2. Okay, so remember your function. So the table, guys, is just a matter of substituting the values that you are given. F of x is equal to x cubed minus 2x plus 3. So you substitute the values that you are given. Remember this table, it is taken from -2 to 2. So that's -2, -1, a 0, a 1, a 2. So you substitute the values that you're given in place of x. -2 to the exponent of 3 minus 2 into -2 plus 3. So you're going to obtain -1. You do the same. When this is -1, in place of x, you substitute -1. That was going to be a 4. In place of x, you substitute a 0. You're going to obtain a 3, a 2, a 7, like that. Okay, so this one was straightforward, guys. That's how you draw your table. From there, we are given, draw a neat graph. So you're supposed to have a neat graph. From this table, draw a neat graph of f of x between these values to show the turning points on it. So you must show the turning points. Remember, the turning points you already have calculated this. You just need to show them. It's not like you're having anything that is accurate there. Okay, so this is just like a sketch, 3.13. So I'm just gonna present it this way. The maximum value there for y is at 7. This, guys, just gonna be an approximation. Do not worry for that. Okay, so let's say this is our y, this is our x. Then we've got 0, 1. Let us just say we've got 1, 2, 1, 2, and so on. -1, -2. Then -2. Then we've got 2, 4, 6, 8. Okay, so -2, -1, -2, -1 might be just somewhere there at -2. -1, 4, -1 versus 4, somewhere there. 0 versus 3, somewhere here. 1 versus 2, somewhere here. 2 versus 7, somewhere there. But remember, as you are to join this graph, you're joining knowing that there are turning points, and these turning points are in between 0.86 and this -8.816. By just looking into these turning points, you see that minus 0.86 is just approximately just here below -1. So maybe and 4, maybe somewhere there. So it's gonna reach a turning point, and 0.86 versus 1.99, just below the 2 and somewhere there. So it's a turning point there. So as you are to draw, you must consider that they are turning points. So this point here is supposed to be a little bit up. This one for 1 is supposed to be a little bit up. Okay, so let's see how it was going to be like. It was going to be like this, passes through a turning point. So this is a turning point, it goes back. So that one is a turning point, goes back. This one is a turning point, it goes back like this, okay? So this one, guys, I'm just sketching how it was supposed to look like. That's your f of x. So the turning points, as you are given, you must indicate these turning points. So it got a turning point at positive 0.86. It was 816. Remember, one is positive, another one is negative. So positive is on the right side. Then the negative one, that's negative 0.816 as to 4,089. So that's our other turning point. So these are the most important to indicate. According to our question, they wanted you to show these values, show the turning points on it. All right, then on 3.14, 1 root of this equation is close to negative 1,9. Use Taylor's Newton's method once to determine a better approximation of this root, just once. So the question is, what is our formula for the Newton's Raphson's method or the Taylor's method? What is the concept? Okay, so remember it states that if I am to determine from the x naught that I'm given, which is the first solution, I'm going to take it as negative 1,9. From that solution that I'm given, if I am to determine x1, it is going to be x naught minus f of x naught, everything over the first derivative having x naught. So meaning to say, we need from our f of x to substitute this f naught. From our f of x, remember our f of x, that's our function, and this derivative, we had that before. So we just need to substitute. Okay, let me just show it here. Remember, our f of x, it was x cubed minus 2x plus 3. So you substitute now minus 1,9. In place of x, you substitute minus 1,9. So that was going to be minus 0,059 to 3 decimal places. You do the same thing on the first derivative. Here, you're going to need the first derivative. Remember, the first derivative, we calculated this, it was 3x squared minus 2. But you have to substitute now when this x is minus 1,9 into the first derivative. You substitute in place of x. Here, where there is x, 3 into minus 1,9 squared minus 2. You were going to obtain, that was going to be 8,830 to 3 decimal places. So this is what you need, guys. Remember your formula. So you're just going to substitute x naught minus 1,9 minus f of x, which is what we got in this case here, minus 0,059. Everything over the first derivative of this substituted, which is 8,83. Okay, so there we can simplify, guys, on our calculator. That's negative, negative, which is a plus. You simplify everything on your calculator to 3 decimal place. That's negative 1,893. So that was, remember, it was given to apply this once, only once. This is what you're given. You must consider also, because you might be given 2 times, you have to apply it again. But in this case, it was apply this method once. All right, then 3.2, you are given, find a pair of positive numbers that have a product of 256 and minimize the sum of 4 times the first number and the second number. Okay, let's get our statement here. From this, we are given there are two numbers, positive numbers, a pair. Find a pair of positive numbers. We do not know these two numbers, so they can be x and y. These two numbers can be x and y. These are your numbers. But what is happening with these numbers? That you have a product of 256. The two numbers, if you multiply them, x times y, the product is 256. And minimize the sum of 4 times the first number and the second number. So 4 times the first number. So there's a sum there. 4 times the first number to the second number. So if this is our first number, this is our second number. The first number is the one that is multiplied by 4. Then you add to the second number. So this is the sum, this one. This one is the product. But they are saying it must minimize this sum. It must minimize this sum. In order for you to minimize this sum, we are talking about those applications of our derivatives now. Minimum values. What is it at minimum? Maximum values. So it's a sum that we are given that we can even write in a shorter way that you do understand that this sum is given as 4x plus y. It is in terms of x and y. And for this sum to be minimum, the first derivative must be equal to 0. But now, is it going to be the first derivative with respect to x or with respect to y? It must be in terms of one letter considered. So in order for you to consider any letter, go back, since these are two equations. There is an equation that you're given, the product there, which is equal to 256. We can work from that equation. Either you make y the subject or you make x the subject. Substitute here so that this is written in terms of one letter. So let's say I make y the subject, I divide by x, it was going to be 256 over x. So this is y in terms of x. So I can write this sum in terms of x in place of y, that is 256 over x. We just substituted what represents y in terms of x. Meaning to say we have just written our sum in terms of, we have got something in terms of x that we do understand, which is 4x plus, remember 256 over x is same as 256x to the power of minus 1. For you to differentiate, you must have x raised to a certain power. For this to be minimum, first derivative must be equal to 0. We do understand on our maximum and minimum values. Since this is with respect to x, meaning to say we are going to need its derivative with respect to x. That is 4. Drop the exponent, that is minus 256x to the exponent of, you subtract 1, so it's going to be a minus 2. So this is our first derivative. But we are saying it must be equal to 0. This is no longer an expression once it is equal to 0 like this. It is now an equation where you can solve for x. You can solve for x. It's now an equation. So from there you can solve for x. It's now a normal equation that you have. So let's solve for x. This same as over 2, 1 over x squared. Remember from your laws of exponents. So you can use the same approach. 4. Okay, sorry for that, guys. So this will be a 4 minus 256 over x squared equal to 0. I can even transpose this. 4 is equal to 256 over x squared. It was a negative, here it will be positive. Over 1 cross multiply, so that will be 4 times x squared. 4x squared is equal to 256. You can even divide by 4 both sides. So this is going to be x squared is equal to 256 divided by 4, which is 64. All right, how do you remove the square? Introduce the square root. So meaning to say x is equal to plus or minus 8. But they mentioned about these two numbers that they are positive numbers. So x cannot be a negative 8. So therefore, our x will be positive 8. But there are two numbers. If one is x, which is 8, what about the other one? Other one, remember, is y. And y is equal to what? 256 over x. From that equation that you formulated, you're going to have your y from there. 256 over x. So y is equal to 256. Our x, we got 8. So what is the value of y? That is 32. So these are the two pairs of numbers that will satisfy that condition that you're given. So you see, guys, it is a matter of understanding of persons, but not that much. We are not given that much. Form an expression on what is maximizing or minimizing, or on what is given that he has got a maximum or a minimum consideration. It is the one that you work with. The one that has got a maximum or minimum consideration. You form an expression. That expression is the one that you're supposed to work with on the derivative concept. The first derivative must be equal to 0 for any maximum or minimum. All right. Then on 1.3, we are given again another part of applications again, where you need to apply the information that you're given there. 3.3, we're given an ice cube with 15 centimeter side. That's a cube. All the sides are the same. So it is melting so that the volume, its volume decreases at this rate. How fast is its surface area changing? Okay, guys, this is a cube. Okay, that's 3.3. Let's see. There we have got a cube. Remember, a cube, all sides are the same. All sides that you're given. So I'm just gonna present my side as L, length, 15 centimeters. We are told that the volume of this cube decreases. That's a negative. A decrease, that's a negative. So it was going to be like this. The V was, it's from volume, remember? With respect to time, that's a negative 9 cubic centimeters per second. Remember, this is per time, per second. dt, in this case, sorry, per time, that is per second. We have an approximation that we're asked to find how fast this surface area is going to be changing. Surface area. How fast is the surface area? So they want you to find dA dt. How fast with respect to time. Area with respect to time. I want you to be careful with this type of a question, because as I said before, on your rates of change, you're supposed to formulate. You're supposed to formulate from the shape that you are given, the properties of what you have. are the volume, the area. So the question is, how do you calculate the volume of this cube? The volume of a cube that is side times side times side, side to the exponent of 3. So as for me, I write this in terms of L, so that's L to the exponent of 3. What about the area? The area, which is the total surface area. Remember, a cube, it has got 6 faces. Each face has got an area of side squared. But in terms of mine, that's L squared. This is the expression of the area. I said that we are supposed to have the derivative of A with respect to T combined from area here. But I want you to see what is going to happen here. The area, it gives us dA, dL. This is what we can get. From the volume, we can get dV, dL. This is what you can get. Okay, we can even find this. This is 3L to the exponent of 2. Okay, drop this one, that is 12L. Is that so? 12L. Just gonna multiply and subtract 1, 12L. Guys, this is what you're obtaining from these derivatives. So if you are to find this one, how are you going to connect the A dt with the dA dL that you're given here? It was supposed to be like this: dA dL times, in order for us to have a dt, guys, here. I mean, for us to have this dt here, we are supposed to multiply with something that is carrying the t. In this case, I mean, there's something that cancels this dA, and the t remaining. So it must have the t, but the dA is supposed to cancel. This dA is supposed to cancel. But the question is, which part is going to cancel? Because if you are to use that now, it does not work. We do not have a t that we're going to use here. From what we are given, we do not have. Because there is dA. Guys, very sorry for that. You see me now. This is a dL like this. So in this case, we do not have anything that carries L and time. But in actual sense, we're supposed to have something that will give us this t. So meaning to say, you were supposed to have dL over a dt like this. dL over dt. But we do not have that. We are not given how the length is changing with respect to time. No, we are not given this. But this was supposed to be your formula. It was supposed to be like this. So this has to be removed. But how? But how? That is the question. Because, guys, this formula, you're supposed to know that once you formulate a formula, this must cancel. Check dL cancels like this. You remain with dA dt, which is dA dt. If it does not give you this, it means your formula is wrong. That one I do not want. Is your formula is wrong. It must give you this. It must cancel. We have got dA dt, dA dt. But how? We have to figure out again another part where dL can be determined. Where is it that we can have this dL? From the volume. Go back to the volume. That's why I've got two things. We can't be given something about area and volume at the same time. They gave us because of this. So there are so many ways that you can actually formulate, guys. There are so many ways. So let me just quickly talk about this. So we need this part because this is to be removed. So we are going to take it from the volume, just like what we had on our area. How are you going to create this formula for the volume? From volume. All right, let me quickly have this. From volume. So from our volume, the derivative was supposed to be dv dt, just like what we are having here. So it was going to be dv dl, okay, times dl dt, so that this dl and dl cancels. You remain with dv dt, dv dt. This was supposed to be the formula for the rate of change of this that you are given here, and you have it. What about dv dl? We have it also. So we have this, we have this. Guys, we have these ones, dv dl, we have it. But this dl dt, this one, you see it, this is the one that we need here. So we are going to take it from the volume. Remember, this is the one here. It is the same. So let's make it the subject from our volume here. How are we going to make it the subject? You simply have to divide by dv dl. You simply have to divide, or just substitute, guys. dv dt, you have it. dv dt is what? -9, so that you do not have confusion. -9 is equal to dv dl. You have it also. dv dl is 3l squared. You simplify this. 3l squared times dl dt. You remove the, you take this, you make this the subject because it is the one that is missing here that we want there. So you're going to divide by 3l squared by 3l squared. So this one was a complicated question, very complicated, because you needed to figure out what is happening. So this and this was going to cancel, and -3 over l squared. It's just a formulation of formulas. So we have got dl dt, this one. Guys, you do not just find something that is not part of your formula and you remove it by erasing by your pen like this. No. It must be substituted by something equivalent. So we have got the equivalent now. So this formula is now valid. We have this. We are supposed to remove it, but we have the equivalent. So we are going to remove it by what? By substitution. By substituting with that dl dt. So meaning to say the rate of change of area with respect to the time is going to be dA dl, which is, we have it, dA dl, remember we have this, that is 12L, times dl dt. dl dt, we got it, that is -3 over L squared, just like that. Just like that. So you see how they try by all means to make sure that you do not get the sense of this. They were hiding this information. You are used to, when they give you this direct, you have got the one for area with respect to length, and this one, the rate of change for the length with respect to, you already given, you just substitute. The only thing that you have to do is to find the derivative of area with respect to length. But this one, it was to be combined. The volume is not what we are working with, but it is giving us something that we need on where the area is to be used. So it can be like that. So with this now, we can determine our rate of change. So the rate of change with respect to time there for the area was going to be what? If you simplify, that's L into L squared, that's going to be L. So it's going to be, this is over 1. So it's -36 over L. So this is our expression for the rate of change of area, but we are given the length. This one is a fixed value that the cube, the length is 15. So we're going to substitute our length in place of L, 15. So that's -36 over 15. So that was going to give us -2,4. So a negative, meaning to say it's a decrease. Okay, so remember, this is area with respect to time per second. So that was the rate at which this area is going to change. It was going to change at negative 2.4 square centimeters per second. Remember also the volume there is decreasing. So the area is also affected with the negative. It's going to be decreasing at minus 2.4 square centimeters per second. So guys, you see how these questions can be like where you have to figure out how is the question given? How am I going to attempt that question? That is how these questions are given. So you just have to be careful. The approach to each question is very, 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 very important. On question number 4, let us try to analyze what we are given. Determine the integral of y with respect to x in each of the following cases. All right, 4.11. This is what we are given. Let's try to figure out what is exactly that is supposed to happen there. That is 4.11. So you asked to determine the integral of y with respect to x, and y was given as the tan to the exponent of 4, square root of x, the sec squared, square root of x, and there is a square root of x with respect to x. Actually, this seems more of a repetition of this question of this nature. Actually, if you think of your substitution, there is something about the tan, because the tan can be differentiated to give us a sec squared. So let's think of a tan. So you're going to think of the substitution method. Let the u to be equal to the tan, the square root of x. So let's differentiate the derivative of u with respect to x. So remember tan, this is the same as we've got tan x to the exponent of a half. The x is the one that is raised to the exponent of a half. So do not worry about that. You focus with the tan. Remember, you differentiate your trig, which is the tan. Tan gives us a sec squared. So that's a sec squared, the square root of x. But you must multiply your answer with the derivative of that function that is given there. So that is where you differentiate it this way, that is where you write it this way so that you can differentiate. Remember, you drop the power, then you subtract 1. So it will be x to the exponent of minus half. Guys, we can even try to simplify this. That is, remember, 1 over again. So we have got sec to the exponent of 2, the square root of x, everything over 2, x to the exponent of a half, which is the same as the square root of x. So we can at least leave it this way. So this is the derivative of u with respect to x. And remember, what we need here is the dx. So let us make dx the subject. You were going to cross multiply. The dx was going to come this side. This one was going to come this side. So we have got 2 square root of x du, which is equal to the sec squared. So we've got the sec squared, the square root of x times dx. We divide by this since we need the dx. So that means our dx is going to be this part, as it is 2 square root of u du like this over this sec squared. So that will be sec squared, the square root of x, okay? This is where we are. And with this, we can determine our integral by substituting what we have, the dx that we determined, the u that we introduced, which is the tan square root of x. So if we're to substitute this into this integral, this was going to be the integral of tan Remember, where there's a tan square root, it's u, so that means it is going to be u to the exponent of 4, u to the exponent of 4 times sec squared, the square root of x like this, over the square root of x times, we substitute dx. Our dx is what we got here. So this is our dx, which is 2 square root of x du over sec squared, the square root of x. Okay, so that's it. With these guys, we can cancel the square root of x to the square root of x, the sec squared x and the sec squared square root of x. You remain with the 2, which we can take outside of the integral as a constant. So that's 2, the integral of u to the exponent of 4 with respect to u, which is something that is easier for us to integrate. Remember, integration, you add 1 on the exponent, so that's u to the exponent of 5 over 5 plus the constant of integration. So that is it, guys. 2 over 1 times 5 is same as 2 over 5, but remember, u, wherever this u is, it is a tan square root of x. So this is going to be a tan square root of x. Very sorry for that. All right, how did it go this side? So that's a tan square root of x, but this is being raised to the exponent of 5. You can raise the whole bracket like this to the exponent of 5 plus the constant of integration, or you can just write the power 5 here. It's one and the same. So this is how we're supposed to attempt this question using the substitution method. So I do not know, guys, which method you think that you're gonna use, or which substitution that you think was gonna work. 4.12 from our integrals, again, we do understand that we can work out these trigonometric expressions from our identities. All right, so they were given 4.12, the integral of the cos of 2x times the cos of negative 6x with respect to x. So remember, from our identities, the product of a cos and a cos, you're given that from your identities, the cos of A times the cos of B, which is equal to the half of the cosine of A plus B plus the cosine of A minus B. So this identity is used whenever you've got a product of a cos and a cos. So it can be a product of a sine and a cos, a sine and a sine. The identities are given. So make sure that you take the right identity, substitute what you're given. So in this case, meaning to say we are going to substitute, this is going to be half the cos of A plus B. This is our A, this is our B. So our A is going to be 2x plus B, which is minus 6x, plus the cosine of A, which is 2x, minus B, which is minus 6x. So minus, minus, that's a plus. Here, that will be a minus. So meaning to say you were going to obtain half of the cosine of 2 minus 6, which is minus 4x, plus the cosine of minus and minus, that's a plus. So 2 plus 6, that is 8x. Okay. So remember, guys, yes, this is trigonometry again. And from your trigonometry, you understand that cos minus x lies in the fourth quadrant, where cos is a positive from the past concept. So this here is same as cos 4. It is the same. So meaning to say, instead of writing this, I can just write it as half the cos of positive 4, like that. Cos is a positive in the fourth quadrant, so it's still a positive. So that is cos 8x. So you can write it that way, which is fine, or you can present it as a negative like that, it's up to you guys. There was no effect there. So this whole part that we are seeing on our integral can be now written as, that is the integral of what we are given there, the integral of cos 2x, cos minus 6x with respect to x. It is the integral of this. So you can even take the half out of the integral. We remain with the cos of 4x plus the cos of 8x with respect to x. So let's integrate. 1 over 2, you integrate cos. Remember, cos changes to a sign. So that's sine 4x, you divide by the number there, plus a sine again, sine 8x, you divide by the constant, plus the constant of integration. So that's it. So that's what you're going to have. You can even expand by a half, or you can even leave this part as it is. The simplification, guys, is in your hands. What I'm simply trying to say is that you can even multiply by 2. 2 times 4, it will be 8. So it will be sine 4x over 8 plus 2 times 8, which is 16. That one, it's in your hands. You can even have it this way. That is what you're supposed to have. So, guys, you can change a cos from a negative to a positive. That one, it's very, very mathematical from the application of your quadrants. 4.13, the sine squared. Integrate the sine squared of 15 over 4x with respect to x. All right. So I want you to understand this. When working with the sine, we have got the identity that we are supposed to use even for a cos squared. What is the identity? We are given, remember there's a sine, the sine squared of x, but I'm not going to talk with x. I'm going to write it as ax. It is equal to 1 over 2 minus 1 over 2 cos 2ax. Take note. If this is sine squared 15 over 4x like this, our a is important, which is 15 over 4. So this is going to give us 1 over 2 minus 1 over 2, the cosine of 2 times ax, which is 15 over 4x. So if you simplify this, this was going to be 15 over 2. So meaning to say we've got 1 over 2 minus 1 over 2, the cos of 15 over 2x. This here, guys, we are used to this. We can integrate this. So you're going to write in a way of something that you can integrate. And we can integrate this. So in place of this sine squared, this is what you're going to have at the end. And from that, you can integrate. All right, so that was the identity that you needed. From that part, you can integrate with respect to x, a constant, that will be half x minus 1 over 2. Remember, guys, we talked about the integral of a cos. It just changes to a sine. Sine 15 over 2x, you divide by the constant, which is 15 over 2. So that's it, plus the constant of integration. So this here simply means 15 over 2 is like this. It's just like 1 over 15 over 2 like this. So it is going to give us 2 over 15. But it is multiplied by 1 over 2, which is outside, which is actually minus 1 over 2. So at the end, it was going to give us minus 1 over 15. So that's 1 over 2x minus 1 over 15. And the sign remains as it is. That is the sine of 15 over 2x plus the constant of integration, just like that. So these are your typical questions. They're just repeating, yeah, just changing the numbers. This is 15 over 4. Next time, they're going to maybe use a normal number, like just use the sine squared as it is. it is a repetition throughout. Then on 4.14, again, we are given to integrate, and that is, we are given a fraction there, 4.14. So that's the integral of x cubed plus 9x squared plus 24x plus 16 like this, everything over x minus 1 with respect to x. So there we are going to apply our long division. We can't use anything of a partial fraction here. So let's use our long division first. Divide these two, x minus 1 into x cubed plus 9x squared plus 24x plus 16. So remember the concept of your division, the first term always to the first term. X cubed and x, that is x squared. You multiply back here everything. So it's x squared and x, which was going to be x cubed minus x squared. You subtract. That's a 0 here. 9 minus minus, that's a plus. So it was going to be 10x squared. Okay, let's drop what is remaining. There we have got 24x plus 16. Let's divide first term and first term. That is going to be plus 10x. It multiplies everything here. 10x and x, that's 10x squared. 10x and minus 1 minus 10x. We subtract. That's a 0 here. 24 minus minus. So we've got minus, minus, that's a plus. So it's 24 plus 10, which is 34. We drop what is remaining. We do the same thing, guys. The first term always to the first term, 34 and 34. X and x cancels, you remain with 34, and it multiplies everything. This 34 that we are seeing multiplies everything here. The x minus 1, that was going to be 34x minus 34. Then we subtract. That's a 0 here. 16 minus minus 34. That will be a positive 50 minus minus, that's a positive. So 50 cannot be divided into x. We do not have x. So this 50 is our remainder. So meaning to say this whole fraction that we are seeing here is going to give us this part, which is x squared plus 10x plus. So we are just going to rewrite this part here. Okay, let me just even rewrite here. So it's going to be integral of x squared plus 10x plus 34, which is what we got after dividing. But there is a remainder of 50. So we are supposed to take this remainder over x minus 1. So the remainder is 50 over x minus 1. So with these guys, we can integrate this with respect to x each and every term. So that's it. Add 1 x to the exponent of 3 over 3. If you add 1 here, that was going to be a 2. So it's like this, 10x squared over 2, and that's divide and gives us a 5. This is a constant, so it's just going to carry x. 50 over x minus 1, that's 50. The ln, remember this gives us ln x minus 1 plus the constant of integration. So guys, I hope when it is for long division, we understand this, work with this as a separate topic. Make sure that you watch the topics of each and every type of integral in your syllabus. Where you see the integral which is not yet covered or not yet done, let us know. Let me know on the comment section so that we can work on that integral. All right, 4.15 we are given. Integrate this again with respect to x. The integral of the cos of x, and we've got the ln tan of x with respect to x. So in this case, if you are to consider, there's something that is just a little bit hidden, a little bit, which is it's a product. So we think of by parts. Okay, let me write our by parts formula. Remember, it's f of x by g prime x dx, which is equal to f of x by gx minus f prime x gx dx, okay? So we are going to need f of x, a function that you can find its derivative. So the question is, can we find the derivative of a cos? Yes, we can find it. Can we find the derivative of this? Yes, both functions, we can determine their derivative. So do not just choose. Do not just take any. You go to the integral. This g prime is to be integrated to obtain gx. Can we integrate a cos? Yes. Can we integrate a lean tan? Guys, it's going to be something else to integrate that. But we saw that cos is comfortable with anything. Can be integrated, can be differentiated. So this is going to be our g prime because we can integrate this. But since it's difficult for us to integrate this, we are going to choose it to be our f of x. So if our f of x is to be the lean tan of x, therefore, what is the derivative? Remember the derivative of lean, guys, I talked about it. First derivative of f of x over f of x. The first derivative of f of x, we are talking about a tan. The derivative of a tan, which is sec squared x, over f of x, which is the tan of x. But the question is, can we simplify this? Because somehow we might need this in simplified form. Remember a sec squared, sec is taken from cos, 1 over cos. So if it is sec squared like this, it's 1 over cos squared x divided to the tan x. And we understand that the tan of x is the sine of x over the cos of x. So this can be simplified into something that is reasonable. 1 over cos squared x. All right, so we've got 1 over cos squared x, introduce multiplication. So that will be cos x over the sine of x. Let's cancel here. That will be the cos of x because there are 2 of them. So we're going to remain with 1 cos. So it's going to be 1 over the cos of x, the sine of x. So this is the first derivative of our f of x. So as we know that by choosing f of x, we are remaining with the g prime x dx. So from what we chose here, what is remaining, the cos x, and this represents our g prime. So meaning to say, in this case, our g prime x dx is the remaining part, cos x dx. You integrate that to obtain gx. So that's it. The integral of a cos, that is a sine. So we've got the sine of x. So guys, this is direct and straightforward. Now we can use our formula. So this whole integral that we are given there, which is the integral of the cos of x, the ln tan of x, can be substituted into this formula, f of x by gx, which is our by parts formula. So what is our f of x? Ln tan x. So that is ln the tan of x times gx. What is our gx? Our gx is the sine of x. So on our formula, we are going to subtract minus the integral of f prime x. So we need minus the integral of f prime x. This is our f prime x, which is 1 over cos of x sine of x by gx. So we need gx dx, and our gx is sine x. We calculated this before. So that's sine x dx. So that's it. We used, or we've applied our formula. Everything is there. Everything is there. So we can simplify further the product of these two. So you can even write this as the sine of x ln tan x, so that you do not confuse yourself here. Minus, here we can cancel this and this. We are remaining with 1 over cos. But the question is that, can you integrate 1 over cos? Is it possible? It's difficult. what is 1 over cos? That is sec. So you've got the sec of x with respect to x. This sec of x is given direct from your formula sheet. Direct from your formula sheet as it is. The sec of x is ln the sec of x plus the tan of x. So this one, do not worry, you can check it from your formula sheet. So that was what we're going to have at the end by applying our by parts method. It's a product. We've got two terms. So you need f of x, you need g prime x. So you do not just take any term that you think this one, no. Analyze your terms first. Which one is it that I can take as my f of x? Am I going to determine its derivative? The one that I'm saying is the g prime. Am I able to determine its integral of this? So in most cases, you choose your f of x. Later on, you see that no, this gx, this g prime x, I can't determine the integral. You start again. Choose wisely so that you do not waste time in exam. All right, 4.2, determine the integral of y with respect to x by resolving the integral into partial fractions. This must be given by resolving into partial fractions. Integral of the whole of this fraction. So what is it that you're supposed to do or apply? Remember, our partial fraction is going to depend with the way that you are going to have this. But for repeated linear factors, this is a linear factor. But repeated to the exponent of 3 means it's repeating. So remember, how do you express this into partial fractions? So it's going to be x squared plus 2x over 2x minus 3 to the exponent of 3. So you just take these 2x minus 3 from 1 up to the power of 3 that you're given. So it's going to be a over 2x minus 3, meaning to say it is to the power of 1. But there's no need for us to write that power of 1. Plus, we move on, b over 2x minus 3 to the power of 2. We are increasing until the power that you're given. So it's c over 2x minus 3 to the power of 3. That's how you work out a repeated linear. Or you can start with that power, reducing until a 1. It's up to you. Or you start with a 1 until that power. It's up to you. So this is it. We can combine this. Remember, take your numerator, x squared plus 2x plus 1 is equal to a. This into this bracket, meaning to say we are going to remain with 2 brackets of 2x minus 3. These 2 into this, we are going to remain with 1 bracket. So it's b into 2x minus 3. They are 3, they are also 3, so they cancel. We are just going to remain with c. If I let this bracket to be equal to 0, it's fine. Then solve. But it's going to be complicated. Just expand these brackets, collect the coefficients, the ones that are corresponding. You can solve for this direct. What is it that I'm trying to say? If we are to expand here, this is x squared. So let's expand. So we are going to have x squared plus 2x plus 1. Okay, so here you're going to expand. Remember your concept of a minus b squared, which is equal to a squared minus 2ab plus b squared. So that will be 2x squared, 2x squared like this. So it's going to be 4x squared times a, okay, minus 2ab, minus 2 times a, 2x times b, which is 3. So it was going to be 12. Okay, minus 12x. But there is an a there, so it's going to be, okay, minus 12x. Then you multiply by a. Guys, let me just do this. Let me just do this. The first one, it was 4x squared. You multiply by a. This one, it's minus 12x. You multiply by a. All right, so the last term is b squared. So b squared, that is 3 squared, which is 9. So 9, you also multiply by this a. So you expand by a each and every term. So that is it, guys. Let's expand b here. So it's going to be 2xb, b and minus 3, that's minus 3b plus c. So by expanding, we can consider the coefficients in this case. So you can work with the coefficients of x squared. Equate the coefficients of x squared from the left-hand side of your equation. There is the coefficient of x squared, which is 1. It is equal to every part that we have where there is x squared. What is the coefficient of x squared? So there we have got x squared. So there is 4a. So the part of x squared is equal to 4a. So you can solve for a. We do not have any other x squared there. So we can divide by 4 by 4. So a is 1 over 4. According to this part, our a is going to be 1 over 4. We do the same thing for b. There we are working with the coefficient of x squared. So this time we're going to work with the coefficient of x. Where there's x, the coefficient on the left-hand side, there is 2, is equal to, we need wherever there's x. So there is x here. What is remaining is minus 12a. Okay, there's also x here. What is remaining is 2b. So that's the only part that we have. So meaning to say this, we have taken it, this, we have taken it. So that's it. Our a, 1 over 4, we can substitute in place of a. We're going to substitute here 1 over 4 because we've got this value of a. So 2 was going to be equal to minus 3 plus 2b. Take it to the other side, it adds. So 5 is equal to 2b. And the b is going to be 5 over 2. All right. So we still have a constant, another one, c. So for c, we can work with the constants. The constant 1 is equal to, we're going to take all these constants which are remaining. There is 9a minus 3b plus c. So you have to substitute the a that you calculated. Remember, we have got our a that we calculated 1 over 4. B, we also have this value of b, 5 over 2. So you substitute these values. So c was going to be 25 over 4 if you calculate properly. All right, so this, we can substitute in place of a over 2x minus 3. So a is 1 over 4. So meaning to say that will be, I'm just going to write it here, guys, so that I can use this where we see. So remember our a is 1 over 4. So I'm just going to write it here. So it was supposed to be 1 over 4 on top like this. But 1 over 4, we can take the 4 into the denominator, this 4. So it will be like this, 1 over 4 into 2x minus 3. Okay, plus b. Our b is 5 over 2, so you do the same thing. B is 5 over 2. So you leave the 5 on top. You take the 2 down. So it's 2 into 2x minus 3 squared. Or you can just leave it like that, guys. Don't not worry. You can just even leave it as it is. Okay, the c, again, 25 over 4. So it's going to be 25 over 4 into 2x minus 3 cubed. So this is what you were going to have after substituting the A and the B and the C. So meaning to say we can integrate this now. We have expressed it into partial. So this can be integrated from what we have here. All right, so how are we going to integrate this? We're gonna take the 1/4 out of the integral. So that will be 1/2x minus 3. You do the same thing on this part, 5/2, you take it outside. So that's 5/2. So this we integrate with respect to x, 5/2, the integral of 1/2x minus 3 squared. Okay, plus, so this with respect to x, 25/4 again, take it outside. You remain with 1/2x minus 3 to the exponent of 3 with respect to x. So this we can integrate the first one. Remember, we are used to our fractions. The integral of 1/ax plus or minus b, it's going to be 1/a, the ln of ax plus or minus b. So meaning to say, if you consider that, it's going to be 1/2, the ln of that part that is remaining. Okay. So that is already, there's a 1/4. So it's going to be 1/2, the ln of this denominator. All right. So you can simplify that. Plus 5/2, the integral of this. How are you going to integrate this part? So there we can use substitution method, the integral of 1/2x minus 3 squared. Okay. By substitution method, we can let u to be equal to 2x minus 3. U with respect to x, that's 2. So dx was going to be du/2 there. So if you substitute, this is 1/u squared, which is same as u to the power of minus 2. In place of dx, it will be du/2. So you take this 1/2 out, integrate this, that's add, remember integral. You are going to be working with an addition of a 1 there. So it will be u to the exponent of -1/-1. All right, so that's minus 1/2 times 1/u. So that's it, guys. 1/2. Remember, u is 2x minus 3. Okay, so this whole part was going to give us -1/2 into 2x minus 3. Okay, plus 25/4. So you're integrating each part. 25/4, you integrate that part. So if you're to integrate this, going to use actually the same concept there. So you're just going to use the same concept, substitution, but this time is to the exponent of 3. So meaning to say it was going to be, okay, it was going to be u to the exponent of minus 3. And this will be du/2. So 1/2, you integrate this, add 1, that's u to the exponent of minus 2 over minus 2. So that will be minus 4 there. So it's going to be -1/4 u squared, like this. Okay, but we know this u, so it's -1/4. Our u is 2x minus 3 being squared. Okay, so that is, this was going to be -1/4 into 2x minus 3 squared. So using the substitution method, you can integrate that part. Guys, there are so many ways that you can use to integrate. Actually, if you know, you can apply those typical ways. So this, we have integrated this, integrated this, integrated this. So that's, we're going to have our constant of integration. So now we're just going to combine and see 1/2 and 1/4 and 1/2. That is 1/8. If you multiply, that's 1/8, the ln of 2x minus 3. So if you multiply this one and this one, that's minus 5 over 2 times 2, which is 4. So it was going to be minus 5 like this. Okay, sorry guys, minus 5 over 2 times 2, that's 4 into 2x minus 3. Okay, you do the same thing, the 25 and the minus 1, so that's minus 25 over 4 and 4, that's 16 into 2x minus 3 squared plus the constant of integration. So that is what you can actually do in your integrals. You can apply that way. Like I said, on the expansion part, that one, someone can start with a 3, 2, 1, can start with 1, 2, 3. It's up to you. But you have to express into partial fractions, then integrate thereafter each and every term using the basic integral that suits for that integral that you're given. So in this case, the substitution would have worked in this integral. 7 marks. Okay, that was a lot. Anyways, guys, you have to revise. As you can see, if you're given such type of a question exam, that's a lot. Question number 5, evaluate the definite integral given the limits 1 to 5, that's x to the exponent of 4, the ln of x. What a direct question here. So we're asked to integrate x to the exponent of 4, the ln of x. The only thing that they just want you to do is to apply the limits of which you are used to these limits. So there's nothing, guys, the product. We talked about this product by parts. Remember, our by parts method, f of x by g prime x dx is equal to f of x by gx minus the integral of f prime x gx dx. So in this case, remember I said we must test. We can differentiate this, we can differentiate this. Both can be differentiated. But let's talk of the integral. We can integrate this. But what about this one? It is difficult. For you to integrate a ln, it's by parts again. So you see, instead, you're going to choose it to be your f of x because it can be differentiated at least. So by choosing this to be our f of x, that means the g prime is the remaining part now. What are we remaining with? That becomes our g prime x dx. And that's x to the exponent of 4 dx. We can integrate that. Okay. From our f of x, what is it that we need? Its derivative. So the first derivative of a ln, that's 1 over x. And from this, we integrate so that we obtain our gx. And that is adding the power, dividing by that new power. So that's it, guys. We can substitute into whatever that you are given. So this whole part that we are seeing, it was going to be equal to f of x, which is the ln of x, times gx. So this f of x, you multiply to gx, which is x to the exponent of 5 over 5, minus the integral of f prime x, which is 1 over x. We have it here, gx, which is x to the power of 5 over 5 with respect to x. So we are going to integrate this and put into the limits that we are given. So meaning to say, that is the whole integral of what we are given, x to the exponent of 4, the ln of x with respect to x. And that is going to give us what if you simplify. So here you can even start with this x to the power 5 over 5, the ln of x minus, let's say x into this is going to be x to the power of 4. So you're going to take the 1 over 5 out. So it'll be like this, 1 over 5, the integral of x to the power of 4. So it's going to be 1 over 5 times the integral of x to the power 4 with respect to x, that's x to the power 5 over 5. Meaning to say this and this gonna be x to the exponent of 5 over 5 times 5, which is 25. So that's it. So we can integrate this. That is what you're going to have with our limits, because there are limits there, 1 to 5. So that was the idea there. So with our limits, remember upper limit minus the lower limit. In place of x, substitute 5 to the exponent of 5 over 5, the ln of 5 minus, in place of x, 5 to the exponent of 5 over 25. That's our upper limit minus the lower limit in place of x. So this is 1 over 5, the ln of 1. Here it's going to be minus 1 over 25. So that's it. You can simplify everything, guys. On your calculator, simply means upper limit minus the lower limit. So this was going to be 880,899 minus this part here. You're going to obtain minus 1 over 25. So thus we can simplify, and we have got 880,939. So it's a direct application then. Substituting of the limits that you are given after integrating whatever that you are given, you substitute your limits. So that is it. So in this case, you needed by parts method. Then after that, apply your limits. So that was our question on 5.1. 5.2, this is the question on our Laplace, the Laplace transform. So you are given there, state the value, you are not calculating anything, you are just stating the answer. So remember that the Laplace of t is equal to 1 over s squared. So when given a constant, you just multiply by a constant. So this is the Laplace of t over 7. So 1 over 7, it's a constant. So it's like 1 over 7, the Laplace of t. And that is 1 over 7 times the Laplace of t, which is 1 over s squared. So that's it, 1 over 7 s squared. So make sure that you watch the video on the Laplace transforms introduction. I talked about that simplification, but in this case, they do not want you to apply any integral, just to state the answer. All right, 5.3, given below is the graph of the functions f of x, which is, we've got this f of x, which is 9 minus 3x, and another f of x, which is this one, of 9 minus x squared over 4. So this is the one on top. Can I consider y1, y2, okay? So this is the one on top of 9 minus x squared. So that's 9 minus x squared over 4. Okay. And this one, it's of 9 minus 3 over 2x. Okay. So there we are given 5.31. Calculate the magnitude of area. 3 marks. All right. So remember, guys, our area is simply the integral. We can see according to the limits from 0 to 3 to 6 there. So you can use the representative strip, in this case being for x. So that is, we can calculate our area in that case. Remember, our area with respect to x is simply integral of y1 minus y2 with respect to x. Our limits taken from 0 to 6, which is our a and b. All right, so that is, in this case, y1, the one on top. We are talking about the top minus the bottom graph. The graph that is on top is this quadratic of 9 minus x squared over 4. So you're going to subtract y2, which is the one on the bottom, which is 9 minus 3 over 2x. So that's it. We're going to integrate this with respect to x. with our limits from 0 to 6. That's from 0 to 6. Already given the limits at the point of intersection. From the point of intersection, x there is a 0, x here is a 3. So that's it, guys. Can we integrate this? No, we can expand the brackets. Then we can integrate after that. So that's 0, 6. If you expand, this one is going to be a negative 9. Negative is going to be a positive. So there is negative, which is going to be a positive, 3 over 2x. So meaning to say 9 minus 9 was going to cancel. You remain with minus x squared over 4 and the positive 3 over 2x. With respect to x, we can integrate this. So that is our area with respect to x. Let's integrate. Add 1 on our exponent, that will be a 3 minus x cubed. We divide by that 3 here, so it will be a 12. Do the same thing here, that will be 3 x to the exponent of 2. So it must be 2. If you add 1, then it multiplies this 2, so it's going to be a 4. So that's it. So in this case, guys, we can substitute our limits. Okay, upper limit minus the lower limit concept. In place of x, we are going to substitute the first part, our upper limit. That is 6. So that's negative 6 to the exponent of 3 over 12 plus 3 into 6 squared over 4. So we've got our upper limit minus, by just looking, there's a 0 here. So that's a 0 there. So the first part there was going to give us a 9. You simplify everything properly. That's 9 minus 0, which is 9 square units. Remember, our area measured in square units. So that is how we could have calculated your area. From there, it was to calculate the volume. So remember the volume again, it is just same approach as of area, the strip that you had, but only the formula is the one that is going to change. So that's 5.32, the same way that you calculated, but remember volume is pi. The integral, you're going to have y1 squared minus y2 squared, which is the top minus bottom concept. So in this case, we have got our top function. Remember, it was 9 minus x squared over 4, but only that this time you're going to square it. Minus y2 squared, it was 9 minus 3 over 2x, but it's only that you're going to square it. So that's it. Our limits, they are not going to change from 0 to 6. So there's no change there. So we must expand these brackets so that we can integrate. So you go back to the expansion of the brackets, 2 brackets, or use your laws A minus B squared concept. Remember the A minus B squared concept, which is equal to A squared minus 2AB plus B squared. So if you were to apply that, in this case, you were going to obtain the first bracket, this one, you were going to obtain something like 81 minus 9 over 2x squared plus x to the power 4 over 16. All right, minus, you expand the second bracket, it was going to be 81 minus 27x plus 9 over 4x squared. Make sure that you expand, guys, properly, each and every part. So if you're to expand again, because we've got a negative that is affecting the second bracket, so it's going to be negative into this, which is negative 81, negative, that's a positive, negative into negative, that's a negative 9 over 4x squared. So we no longer have this, we have used it in this bracket. So that means we can combine our terms. We can combine our terms before integrating in this case, all right? So let's combine the 81 cancels. Okay, we've got like terms here, x squared, so it's minus 9 over 4x squared minus 9 over 2 and minus 9 over 4. So that was gonna be negative 27 over 4 x squared. There is x to the exponent of 6. This one, I mean, this 16 here on its own. This, okay, so it's gonna be x to the exponent of 4 over 16. Okay, there is a 27x there, positive 27. So we are remaining with positive 27x also. So that's it with respect to x. Remember this, we combined it there. So with this, we can integrate. It's not that much complicated, guys. We just have to be very, very patient and try by all means to be careful, because as you can see, we are working with a lot of things. So you must be careful. So now we can integrate. So this one was going to give us what? Negative 27 over 4 times, remember you add 1, so it was going to be x cubed over 3. Multiply this, you were going to obtain negative 9 over 4 x cubed. Okay. You do the same thing here. Add 1, so it's x to the exponent of 5 over 16 times 5. And 16 times 5, that's 80. So it was going to be 1 over 80 x to the exponent of a 5. At 27, you do the same thing, we add 1. So that was going to be 27 x to the exponent of a 2 over a 2. So this one, there is no effect there. From 0 to 6, which is, we can substitute our limits, guys, and that was going to be in place of x, a 6 wherever there's x. So negative 9 over 4, 6 to the exponent of 3, 1 over 80, 6 to the exponent of 5, 27 into 6 to the exponent of 2 over 2, like this. So that is your upper limit in this case. Minus, that's a 0 there, guys. Substituting a 0, there's nothing there. So that's a 0 there. All right. So this was going to give us the volume with respect to x. So this whole part simplified was going to be something like 486 over 5. You multiply to pi. It was going to be 303, 305 actually, 363 cubic units. Remember, this is volume. So it's going to be cubic units. We are working with the cubic units there. All right. So guys, it seems like there's a lot of calculations there. We just have to be careful so that you do not miss any value. But that's your volume. That's your volume. And they are going to ask typical questions of this nature. So make sure that you do work on much questions as you can. We are given to calculate the second moment of area of a rectangular lamina, which with size 12 centimeters and 8, about an 8 centimeter side, about this side. So if it is about this side, therefore our moment of inertia is going to be the longer side for x, the shorter side is for the y. So this is the length, like the one that you're given, a rectangle like this, 12, meaning say from 0 to 12, and this is 8 from 0 to 8. So the 8 is for the y. So in that case, we're going to have the moment of inertia from r squared times the dA, whereby the r is supposed to be taken from the strip that you are working with, perpendicular to what? To the x-axis. So when perpendicular to the x, it means you're going to substitute this as x squared. Then dA is the area expression. So our dA, that will be the side times dx. So we have got our dA, so we can write our moment, our second moment, as r squared, which is side perpendicular x squared times our dA, which is 8 dx, meaning we need an integral when the limits are used. So meaning to say, what is going to be our integral in this case? We're going to have 8 out of the integral of x squared with respect to x, our limits 0 to 12. So that is with respect to x, our limits will be from 0 to 12. So that means in this case, we can integrate, substitute our limits x cubed over 3 from 0 to 12. That is, guys, okay. Substitute your values there, 12 to the exponent of 3 minus 0 to the x, that's a 0 there. So that was going to be 4,608. So remember, this is second area moment, so it's going to be units to the power of 4. The first area, units to the power of 3. So guys, you must be careful with the strip that you're working with. And the rotation, it's about what? About the x-axis. So you consider that side, or in this case, the smaller side, perpendicular to that longest side that you're given of the x-axis. Question number 6, determine the general solution of this. Determine the general solution. That's 6.1. So we're given x divided x is equal to x plus 1 plus xy plus 1. So we do know that in order for us to find this, to solve this differential equation, we need to separate the terms of x to one side, the terms of y to one side, that is by separation. But how are you going to separate now? Because we've got x there, a lot of things, y there. So if you are to check properly the right-hand side, they wanted you to be very, very much confused here. But there's nothing. These are 4 terms, meaning to say you are supposed to think of factorizing these terms. 1, 2, 3, 4. Remember, by grouping, we can factorize the first part. 1 is common, so it's going to be x plus 1. To have the same bracket of x plus 1, what is common in this bracket? That is y. You remain with x plus 1. The 2 brackets are common, so meaning to say I have got x plus 1 and 1 plus y, which is same as y plus 1. So this whole part here of x divided x was supposed to be given like this, and we are used when it is like this. When they give you 2 brackets, you can cross multiply this and that. Remember, you need to separate. You need to separate these terms. So you're going to cross multiply in this case, all right? This multiplies this side, this multiplies this side. 1 times there's x divide x, x dy, sorry, which is equal dx multiplies this side, so it's going to be x plus 1 into y plus 1 dx. So how can we separate the part of dx to x, the part of y to y? There is a product, so you're going to divide by y plus 1 so that it goes to this y here. So divide by y plus 1, meaning to say this side is going to be dy over y plus 1. But there is x here that is there, so you need to divide by this x to remove it. So you divide by the x so that this can cancel. And on the other hand, you will be having x plus 1 over x with respect to x. So you need to separate the part of y on its own, the part of x on its own. Then integrate, but before that, remember that a plus b, if you're given this a plus b over c, it is the same as a over c plus b over c. Meaning to say we can separate by the same denominator that we are given the terms. X over x plus 1 over x. So you see, this was going to cancel. You get 1 plus 1 over x. So this can be written as dy over y plus 1 is equal to 1 plus 1 over x instead. Then integrate. So integrate both sides. With respect to y, you are integrating 1 over y plus 1. What are you going to obtain? That's a ln of y plus 1 is equal to the integral with respect to x of a 1, that is x. 1 over x, remember, that's a ln. So you've got the ln of x plus the constant of integration. You're done. General solution, there's nothing that you need. So you see how they can try to confuse you guys. You are used when you are given from this statement here. This is equal to this. You start to separate. But they wanted you to factorize first by grouping. These are 4 terms, so you can factorize by grouping. All right, another question, which is 6.2. It was determine the particular solution this time. That's, we have got the limits. Okay, anyways, let's see. So this whole part that we are given, that is 1 over 2 minus 5x squared times second derivative of this y with respect to x is equal to minus 3. So remember what we need when it is having higher power, we need to integrate both sides. So we need to get rid of this. How can we get rid of this fraction? Just multiply by it. Multiply by 2 minus 5x squared. Multiply by 2 minus 5x squared. So this will cancel. You have your dy dx. So that is second derivative of y with respect to x is equal to minus 3 into the bracket of 2 minus 5x squared. This can be expanded. Either you're going to use that bracket of a minus b squared, or you open 2 brackets, there you expand. But you're supposed to expand that. That was going to be 4 minus 20x plus 25x squared. If you expand, then you can multiply by negative 3. That's negative 12. Positive 60x, negative 75. If you multiply, that will be negative 75x squared. All right, so there we are just expanding, guys. We are not working anything. We are just expanding so that when we integrate, remember the concept there, we need to integrate to find dy dx. Integrate this with respect to x. We are finding dy dx there. So dy dx will be equal to, integrate this, that will be minus 12x. Plus, you integrate this, you add 1, remember, so it's going to be 60x squared over 2. Divide this, that will be 30x squared. So this will be 30x squared. You do the same thing, you add 1 on the exponent is 3. Minus 75, x to the exponent of 3 over 3. 3 into 75 is what? Minus 25. So that's minus 25x cubed plus the constant of integration. That is where we have to use the first condition of the limits that you are given, dy dx, and the x value we are given that at this moment, when this dy dx is equal to 0, x must be 1. So dy dx is a 0. When x is equal to 1, wherever there is x, you're going to put a 1. So meaning to say this will be minus 12 plus 30 minus 25 plus a. You solve for a, take everything, combine, then take it to the other side. Our a was going to be a 7 at the end. All right. Substitute to that dy dx and continue integrating until you obtain y. From this, we are saying dy dx is equal to minus 12x plus 30x squared minus 25x to the exponent of 3 plus our a, which we calculated, we got a 7. We are not having, we have to solve until y is equal to. So we have to integrate again, just like the previous case. Integrate both sides with respect to x, we obtain y this time. So if you integrate this, what we're going to have at the end? You add 1, that's minus 12x squared over 2, which is going to be minus 6x squared. You add 1 here, that will be 30x cubed over 3. So this will be a 10x cubed. Okay, you do the same thing. That's a 10x cubed. You do the same thing here. You add 1. So that will be minus 25x to the exponent of 4 over 4 plus 7 with respect to x. That will be 7x plus the constant. This time, we're going to use a b. We use what we are given there. What is the relationship at this at this condition? Y1 is equal to minus 1 over 4, meaning to say when x is 1, y is minus 1 over 4. So we are given the value of y, that y is minus 1 over 4 in this part. So minus 1 over 4 is equal, wherever you see x, we are given that at that moment, the x must be what? 1. X 1. From y1, x must be 1 there. This is the indication. We are given the x value. So wherever there is x, you're going to put a 1. So meaning to say this was going to be minus 6, 1 here plus 10, minus 25 over 4 plus 7 plus b. So you can solve for b. Take all the terms. That was going to be 19 over 4, something like that. Minus 1 over 4 is equal to 19 over 4 plus b. Then you take it to the other side. It becomes a negative. So it is going to be minus 5 at the end is equal to b. So remember, we need the particular solution. So therefore, substituting the constant that we just calculated, y is equal to what? We substitute back. So therefore, y is equal to minus 6x squared plus 10x cubed minus 25x to the power of 4 over 4 plus 7x, our b, which is minus 5. So like that, you have got the solution that is y in terms of x. So this is how our questions can be like. Guys, let's revise as much questions as we can. So that was our question paper, guys, which was written April 2020 for exams. So let's make sure that we do revise as much questions from now to cater up for the exams which are ahead of time. But for now, that's it till we meet again.